We know what a point estimate is. We know what a confidence interval, which is also an estimate, is. In the sense that 95% with 95% confidence, if it's a 95% confidence interval, we can say that 95, if we repeat the experiment 100 times for a 95%, 95 of those intervals, confidence intervals, will contain the population proportion or population mean. Okay, and now finally, this is the top topic in this class, the hypothesis testing. So notice that the word hypothesis with an I is a singular, and with an ESES means plural. Okay, so hypothesis test regarding a parameter. Today, if we can cover more than 10.1, maybe we'll move on. I don't have a handout yet for 10.1. For 10.2, but for 10.1, this is what we need to cover. If we finish sooner, we'll do other problems. If not, we can move on to 10.2. Okay, so first of all, we have to understand the language of hypothesis testing because it has particular structure that we have to learn. So a hypothesis, what is a hypothesis? Is a statement regarding a characteristic. So this is chapter 10. Hypothesis testing. And this is basically, as I said, the top topic in this class. Basically everything we've done so far is for this. Okay, so what is a hypothesis? Again, a hypothesis is a statement regarding a characteristic of one or more populations. Okay, so here's our first example. So I'm hoping that you open it up, or I can open it up and share the screen, whatever you want me to do. You want me to bring it up on the screen, or you have it? Okay, you let me know. So in 2008, 62% of American adults regularly volunteered their time for charity. A researcher believes that this percentage is different today. So this is a hypothesis. This is a claim. The claim is that the percentage is different today. So the percentage from the previous studies was 0.62. But this researcher says, no, I think that today is different. So from a previous study, they came up with the idea based on facts, based on sampling, based on research, and so on and so forth, and on hypothesis testing. They came up with the result that 62% of American adults volunteer their time for charity. Okay, so what is the statement? The new statement is this. A researcher says, I no longer believe that today this is the case. I think it's different. So that's the statement that we would like to test. This is a claim. We want to test the claim. Part B, another example. In March of 2006, we have to replace this word. It's the mean. Sorry about that. The mean length of a phone call on a cellular telephone was 3.25 minutes. So the mean was 3.25 minutes. 3.25 minutes. Okay, so this was from a previous study conducted or the results were given or made public in 2006 in March, and that is the mean length of a phone call on a cellular phone based on research, based on experiment, so on and so forth, right? 3.25. A researcher believes that the mean length of a call has increased since then. So right now he claims this. That's his claim. This was the claim before. So we want to test this claim. And there are several steps to do that. So we're going to get to that in a minute. So that was a claim. See the difference between these two? Here the researcher said, not the same with the previous one. Here the researcher said, or the claim is, greater than that. Okay, here's another example. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was, okay, so sigma, 0.23 ounces. With new equipment, the quality control manager believes that the standard deviation has increased. This is the claim. And this is what we want to test. He comes up with a claim, and now we have to say, okay, show me. And we'll see with the steps in a moment. So see the difference? This says not the same, and these two say greater than. What if they said less than for any of these? Then I would have had P equals 0.65, for example, and P less than 0.65. This could have been the claim now. Notice that there are three different types: not equal to, greater than, or less than. But the initial, which is what comes from the previous studies or what is well known, is always equal. The claim could be not equal to, could be greater than, or could be less than. Okay, moving on. Hypothesis testing is a procedure to test statements about population characteristics. It is based on sample evidence and probability. This is extremely important. So hypothesis testing doesn't come out of air. Is based on data coming from a representative sample. As we know, we have different techniques like simple random sample, from a legitimate technique So what I would like to write in parentheses, representative sample of the population to be studied. So the hypothesis testing is based on data coming from a legitimate technique with a sample size of whatever. With a sample size, we always denote that by lowercase n. So the data has to be coming from a legitimate technique, a sample size with a sample size of n, using a legitimate technique that gives us a representative sample of the population to be studied. Also, it is the hypothesis testing. It is based on probability. So not only on a legitimate data, but also on probability. And now I think we are ready to look at the steps. Steps in hypothesis testing. Any questions for me? Any questions, please? Anyone?
Not yet.
Good. Thank you. Here are the steps. We have to make a statement. If there is no statement, then why will I collect data? So if I don't have anyone claiming anything, if I don't have a claim, I have no reason to collect data. If there is a claim that something happened or we believe something, that's our claim. Now we have to support it with a sample and hypothesis testing. Okay, so step number one, we make a claim, or someone makes a claim. In step number two, we collect the sample. So number one, steps. Number one, claim. If there is no claim, there is no reason to do a study. Number two, collect the sample. And it has to be a legitimate one. We're using a legitimate technique. And it has to be representative of the population we have to study. In step three, we analyze the data coming from the sample. Number three, analyze data from step two. And final step, draw a conclusion. Final step, draw a conclusion. I'm on page 2 of the handout. Now, this note here is extremely important. I'm going to read it, and then we're going to write it. I'm going to write it. I hope you do too. We never accept a claim or a statement based on data. Okay? So let's suppose this was the claim. That the mean of a phone call has increased. Is no longer the mean of phone calls is no longer 3.2 minutes to 5 minutes, but it's more than that. So we will never say that we accept anything. We have to say that we reject or we fail to reject what was initially thought of. So we collect the sample, we analyze the data. This is our claim, but we will never say we accept anything. We have to say that this is the language of hypothesis testing. We can only say that we reject or we fail to reject the so-called null hypothesis. That's the language. What does the null hypothesis mean? This is the null hypothesis. We denote it by H sub 0. In all cases, this is our H sub 0. What is known from previous study. Okay. So we say reject the null hypothesis. Or we fail to reject. Based, this is the continuation, based on the sample data at hand that we have. This is extremely important to remember. So every time I conduct these 4 steps and I analyze the data and I want to draw a conclusion, this is the conclusion. I either reject what I knew from the past based on the data or fail to reject what I knew from the past information. And comma, I have to write based on the sample data at hand. What if I repeat the experiment? Will I get the same answer? Maybe, maybe not. So I have to write this based on the data at hand. Okay. We always test the null hypothesis. We always test the null hypothesis based on the data coming from the sample. This is clear. The alternative hypothesis of the statement is the claim we seek evidence to support from the sample information. So that, coming back to this, which is the alternative. Your book calls it age 1. Call it the way you like. I prefer age alternative, H sub A. H sub A, H sub A. So this is what is called the alternative. This is our claim. We are analyzing the sample because we are trying to find evidence to support our claim.
For the old data, sorry to interrupt.
Please do.
You have H of A for the new claim data, and then is that H sigma or H of O for the old data?
H sub 0, it's called the null. H sub 0, the null hypothesis. And H sub A is basically our claim. We are analyzing the data from the sample in the hope that it will support our claim. But ultimately, we are basically testing what was old.
Okay, thank you.
Thank you. Does it make sense?
Sure. Yes.
Yes. So that's why, as I mentioned, chapter 10 is the reason why we studied everything in this class. Everything. As you see, everything is here. Collect the sample. We know what type of sample and what to do with it and how to analyze and organize the data. Then we learn how to analyze the data. And now we are drawing conclusions from hypothesis testing. This is called inferential. We are making inferences, conclusions. We draw conclusions. Inferential statistics. Inferential statistics. We are making inferences. We are drawing conclusions. Coming back, I'm not sure what is going on here. Alternate. I'm not sure. The alternative. I'm going to have to correct this. I'm happy you probably didn't print it out, I hope. Okay, so the null hypothesis, one more time, is no change. No difference, no change, no effect, no difference, nothing. It's the same as we knew it from the past. The alternative, also denoted H sub 1 in your text. Use the one you like, it doesn't matter. It's easier for me to, when I say the alternative, it's easier for me to write this. So this is the alternative hypothesis. Basically, our claim, or the researcher's claim, or something we want to test. Okay, coming back. So we're trying to find evidence in order to reject, or it's possible to fail to reject the null hypothesis. So now we know we're going to get to those three ways.